Good morning everyone. Welcome to question number 2. This is one concept per day total, and in this concept, today's concept we are discussing about the concept on collisions. Okay, collisions as related to circular motion. Okay. So this question is taken from November 2024 paper, and this question is in a loop toy. The car of mass 0.12 kg is released from rest. The initial position of the car is above level ground. The radius of circular loop is 15 centimeter. 15 centimeter. The car reaches the top of the loop at position P. Top of the position P. Okay, fine. Frictional air resistance force is negligible. Right. Show that the speed of the car at P is 1.7 meter per second. So show that the velocity at this point is seen to be 1.7 meter per second. Now how do we prove? What we do is let us consider here the potential energy of the car at this point is seen to be, this is your height h, is seen to be mgh. When the car starts coming down like this, the potential energy starts dropping down, and when it reaches here, the potential energy becomes zero, and all the potential energies got converted into the kinetic energy. And when the car starts rolling upwards over here up the curve, the kinetic energy, part of the kinetic energy gets converted into potential energy, and here it's the sum of potential plus kinetic energy over here. So what should I do? I should just apply my conservation of energy. Nothing else. Let us apply the conservation of energy. Energy here should now be equal to mg into 0.45 meter. Mgh should be equal to, what is the energy here? Mg multiplied by, what is the total distance? 15 centimeter plus 15 centimeter. I mean the total height here, right? So total height here is 30 centimeter. So I can now write this as 0.30 plus half mv p square. Thus, we will find out what is this value. So this should now be equal to, see m is common here, I will remove this m on all the sides. I have g into 0.45, it should be 10 into 0.45, it should be 4.5, minus g into 0.3 should be equal to 3 over here. I am taking this one on the other side here. So minus 3 should now be equal to half vp square. 4.5 minus 3 should be equal to 1.5 should be equal to half vp square. In other words, vp square is equal to 3. Vp is equal to root 3, and we know the root of 3 is nothing but 1.732, which is 1.7 meter per second. Okay, thus we have got the answer as per required. Okay, now let us move on to the next question. Determine the normal force exerted by the loop on the car. So what we need to do, we need to draw a free body diagram here. The free body diagram tells you that if the car is at this point, normal force is acting downward like this. mg is also acting downward like this. So this sum of these forces will be equal to mv square by r, right? So therefore I can now write the equation as n plus mg is equal to mv p square divided by r. I have to use this equation. So I will write n plus mg is equal to mv p square divided by r. Now which should be n plus, what's the value of m? M value, this is given, it's already given 0.12 kg. I will take this as 0.12 multiplied by 10 is equal to 0.12 multiplied by, what is Vp square? Vp square we just calculated here, 3 here, right? So therefore I will just substitute as 3 over here divided by radius. What is the radius here? The radius here is 15 centimeter, which is 0.15 meter. I always convert everything into SI. When I get this value, let us calculate this value to find out the value of n. So this should now be 0.12 multiplied by 3 divided by 0.15. I get the answer is 2.4. So this value is equal to 2.4, while this is n plus 0.12 into 10 is 1.2. That n should be equal to 1.2. What is this? Normal force, Newton. So the value of normal force is 1.2 Newton. Okay. Next. State why the car stays in the loop, stays in contact with the loop. See, any object, the moment it is in contact with the loop, what happens is there is a normal force here. Now let us say this object is not in contact with this surface. What do I mean by it? It is floating. Let us say it is 1 nanometer away from the surface. What's the value of normal force? Normal force n is equal to 0 here, because there is no force given by the surface to the object. Now in this case also, when you have the object like this over here, and the car is over here and this is surface, is it in contact with the surface? Yes. If it is in contact with the surface, then the normal force should be greater than 0. But if it is equal to 0, that means normal force is, that means the object was no more in contact with the loop over here. So what is the normal force we have got? 1.2 Newton, which is greater than 0. As a result of it, the car stays in contact with the loop. Okay. Next, let us move on to the next one. At point A, the car collides with the block of mass 0.18 kg and sticks to it. After the collision, the car and the block moves together with a speed of 1.2 meter per second. So it comes, it hits over here, and then it starts moving at 1.2 meter per second, right? Calculate the speed of the car before it collides with the block. Which means the question is, even before, let us say the car is written like this. This is my car here. This is my object over here. Okay. When I have the object over here, okay, and it is no more in contact with this, then what is the speed of this car before it collides with it? Okay. So how do I solve this? Quite easier. So what we need to do is apply the same conservation of energy. See, I apply the conservation of energy between this position and this position. Now I am going to apply the conservation of energy between this position and this position. What do? I will write mgh is equal to half mg square. Simple. Okay. Therefore, I will write this as mgh at this point. At this point, it was somewhere over here. It was here. This was your height. It was your height. So what I will do is this is 0.45 meters. So I will just write mgh is equal to half m. Let me call this point a c here. Half mvc square. So m and m goes away. So vc square is equal to 2g, which can be written as 2 multiplied by 10 multiplied by 0.45. It should now be equal to how much? 2 into 0.45 is 9. 0.9 multiplied by 10 is 9. So this should be 9. So Vc should be equal to 3 meter per second. So the answer for this one is going to be 3 meter per second. Okay. Let us take up the next example. The surface from A to B is rough. Okay. From A to B is rough over here. Okay. And the combined car and the block come to rest at B because of this friction. So when it hit over here, its speed was what did it say? Okay, it started to move at 1.2. So when it's together, it was there like this. Its speed was 1.2 meter per second. Before collision, it was 3 over here. Okay, and there is a rough surface over here. This 1.2 after some time, what will happen? It becomes 1 meter per second, 0.9, 0.8, 0.6, 0.3, 0.1, 0 here. So here it reaches 0. See what is given here? This is your initial velocity, this is your final velocity, this is your distance. Now you know which equation you can use. V square equal to u square plus 2as. You can easily use this. Okay, now let us understand what else is given. Right, and then come to this. Determine the rate of change of momentum. He's asking you what is the rate of change of momentum of the combined car and the block from A to B. Rate of change of momentum delta P divided by delta T. What is delta P by delta T? It is nothing but force. Which force? How does the car have a force? See, the car came from the larger distance over here. The car came from this larger distance, larger height over here. It gained a larger velocity over here, and it did not have any force on its own. Okay, but when it hit over here, it has been stuck together and it's moving like this. So what is the force you are talking about? It is a frictional force that you are talking, because it is this force that is making the car to stop here after some time, right? So therefore, what I will do is I will consider the work energy theorem, because I do not know how rough is the surface or what is the frictional coefficient. Nothing is known to me. So what I will do is I will just take work energy theorem. When I use work energy theorem, what do I get? I get this as the work done in the motion of the car from F into D is equal to the change in kinetic energy. Change in kinetic energy. What is change in kinetic energy tells you? The half mv square minus the change in kinetic energy. This should now be equal to F into D. I don't know what is the F here. Frictional force multiplied by distance. What is the distance? Distance is 0.2. Now what is this now? Half into, what is this value of M? M is nothing but the total mass of both the blocks. What is the total mass of it? This block had a mass of, how much was the mass? 0.18 kg. This has 0.18 kg, while the car had a mass of 0.12 kg. So sum of these two would be 0.3 kg. So this will be 0.12 plus 0.18 multiplied by V. What is the V here? V here is nothing but the velocity at which the car began to move when both of them were joined together, right? It is 1.2. So I will just write this as V square is 1.2 square minus 0. Okay, some of you might think, why am I writing like this? Because this kinetic energy, delta kinetic energy should be kinetic energy final minus kinetic energy initial. So as a result of this, you should have written 0 minus half mv square. That's what you have thought about it. You can write like this also, nothing wrong. I just skipped one step over here. If you are writing it like this, okay, what should happen? Because I am using my proper sign notation here, right? What is this F into D? F dot D here. What is F dot here? Dot tells you what is the force and displacement, what is the angle between them, right? If you want, I can write like this also here. I'll now write like this only here. This is nothing but F into D into cos of theta is equal to kinetic energy final minus kinetic energy initial. I'll write like this. Okay, no need of going like this. That will create a confusion. I'll write like this. Force is what I do not know. This D is nothing but 0.2. What is theta here? Theta is cos 180. Why cos 180? Because you know F is acting like this. Displacement is like this. The car and the block are moving like this. Displacement is like this. But the frictional force is acting in the opposite direction. The angle between these is 180. That's why I written like this. Which should now be equal to kinetic energy final is 0 minus kinetic energy initial is half mv square. Right? I apply the same thing. So this should be F into 0.2 is equal to half mv square. Because this negative sign, and this will impose a negative sign, right? This negative sign will go away. So you get this one once again here. Now let us write down this. So as a result of this, I will now write F into 0.12 is equal to half mv square. What is that I need? I need the value of F here. So this should now be equal to a half into 0.3 multiplied by 1.2 square. Let me check it with 1.2 only, right? 1.2 square. So when I do this, I get F is equal to 0.3 into 1.2 square divided by 2 multiplied by 0.2. Let us calculate that value. I get 0.3 multiplied by 1.2 into 1.2 divided by 2 is equal to so much, divided by 0.2 will be 1.08. 1.08. Since we are having only two significant figures, I will approximate this to be 1.1 Newton. So this is the answer for it. Now let us move on to the next one. Calculate the dynamic friction of coefficient of friction between the rough surface and the combined car and the block. So what is he asking here? Dynamic coefficient of friction, mu. Okay. So how do you relate when a particle is moving in a straight line in a horizontal surface? Then your frictional force is equal to mu times n, right? Mu times n. What is the value of n? N is nothing but the total weight of the object. Total weight of the object. What is the total weight of the object? See, you have a car and you have an object. Okay, car plus object was weighing 0.3, 0.3 times g over here. I will substitute this. The frictional force is equal to mu times 0.3 multiplied by g. This is what I get. Now, what is frictional force? We just estimated that. What is the value? 1.1 Newton. I substitute that over here. I get 1.1 is equal to mu into 0.3 multiplied by g is 3, because I take g equal to 10 over here. So this one, so mu should now be equal to 1.1 divided by 3, which should now be, how much will this be? 1.1 divided by 3 will be 0.367. It may be around 0.37. So there's the value of mu is equal to 0.3. Right? I think with this we have come to an end to this question. I hope you have understood about how to solve problems in collisions, okay, and how collisions can be merged with either something like in circular motion, okay, or just bouncing of a ball or anything of that matter. Okay, so this is how we solve the problem. So do like, share, and subscribe to my channel for more updates. So we are supposed to be doing more number of problems based on such kinds of concepts. I think so far we have done around 30-35 concepts we have covered, which will be sufficient for an IB2 exam. You can view all this in my website. You can go to my website, whose link is below here, which is, if you want, I can write it down here. https IB physics withrow.com/OC. Okay, this is my link, wherein you will be able to find out all the problems whatever I had done. Thank you.